I would like to demonstrate something to you, which I hope will help you to understand the impact of putting something hot into a container made of plastic. So I have two clean ramekins. I'm going to... Did you stop it? Okay. I'm going to put some cold water in there, the first one. And now I'm going to take this one and put hot water in it. Oh, that's nice and hot. And so the amount is about the same in both of them. I have a ZeroWater filter that I'm returning, but this comes with the filter. It is a total dissolved solids tester. Now the truth is, it's not a total dissolved solids tester, because if you look there, you can see that there are two prongs right there. And that means that this is actually testing the conductivity of the water. So what it's actually testing is things in the water that help the electricity to pass through it. Therefore, anything that does not conduct electricity is not only not counted, but you can't tell how much it's impeding the flow of electricity. So this is a very sloppy instrument for measuring TDS, and it actually just, I don't know, I guess you could say it's only really measuring conductivity. Okay, so I'm going to show you right now. I've got it on 0, which is what it should be. I'm going to put it in the cold water. And we have 237. Can you see that on there? Mm-hmm. Alright. I'm going to take it out. I'm going to shake it out a bit. Now I'm going to put it in the hot water. And it's 294. 3.5, I guess. So, why, if it's the same source, this tap right here, if it's the same source, why aren't the numbers the same? Why is the hot water higher? Well, here's the thing. Whenever you use heat, it produces, it's a form of energy, right? So what's happening is not here in the glass. I could use any kind of material, it doesn't matter. That isn't the issue. In fact, I'll prove it to you here. I'm gonna go back here. I'm gonna turn. So there's no container, and I'm gonna show you if I can't, if it'll even produce.
Whoa.
Okay, this is a little bit difficult because there's no container. But you can see, yeah, basically it has to have a container, but the fact of the matter is the water container is not really important, and in the sense of is the water being contaminated by the glass? No, glass is neutral. It isn't contaminating the water. But what is happening is under the sink and in the walls, right? We have got pipes. And it just so happens, I don't know if you can see it or not. Hold on. Grab this little flashlight. If you see, we've got copper piping in here, right? So what does this tell us? This tells us that when the water is hot, it's the energy of the heated water causes some of the inside of the pipe, which could be the copper, to dissolve into the water. Okay, so it's probably not pure energy energy thing. It's probably a chemical reaction that is made easier by the heat. I did the same test yesterday, and the results were even more startling than today. So basically, when you're running hot water through your pipes, or you're putting it into a plastic container, you are helping to create a better environment for chemical reactions, because that heat represents energy, or is energy. And as a consequence of that, if you take, say, your food, or maybe you have some cider and you heat it up, and then you want to take it with you in a plastic cup. Well, if it's cold cider, there's going to be some reaction, because cider is, after all, kind of acidic. But if it's hot cider, not only is it acidic, but it's got lots of extra energy. So if you were to do that with cold cider and hot cider, you would also see the same result, that there's more stuff going into your beverage. The same is true of foods. The heat, when you're putting food away, you should let it cool down so that it's pretty much room temperature before you put it into any kind of plastic container. If you're using a glass container, you don't have to be as concerned. You just don't want to put it in there when it's too hot, because if the temperature of the glass is different enough from the temperature of the food, the glass will break, right? But if you put it into glass is inert. It is chemically inert, so you don't have to worry about this problem. But if you take your food and you put it into a plastic container, the result is going to be a chemical reaction supported by the heat energy. Now, if you take that food and you heat it up in a plastic container, in say, the microwave, you're giving it even more energy. And that is why, if you notice, sometimes when you have heated something up in the microwave in a plastic container, you'll see that the container becomes damaged. And that's partially just because of the heat, that the plastic is not good enough or strong enough to deal with the heat of, say, the grease that's in the food. But it's also an indication that possibly there was a chemical reaction going on that was encouraged by the energy from the microwaves and the consequent heat that was produced inside of the food or beverage. So my point here is, you should never put anything warm or hot into a plastic container because of this. It's we don't know the long-term consequences of these chemicals that are leaching into our food and beverages from plastic, which is why I try to avoid buying food that would have had to have been sterile before it was put into a container. And if that container is plastic, that means that they probably had to heat up the container, and that means the risk of the contamination is higher before you've even done anything yourself. All right? So just think on that, and hopefully that's useful information for you. Have a great day.